Hey there, today I'm going to return to the subject of fuzzing and exploit development, but this time I'm going to do so mainly without metasploit. Instead, we'll be using a special Python script, first to fuzz, and then to develop an appropriate exploit. Our target program today is SLMail. It's a POP3 server. It's a rather old program and makes use of a Windows XP Service Pack 3 machine, as well as a Kali Linux machine. I'd like to credit the content of this video, or much of the content is coming from a lecture from Dr. Ingebretson. Okay, now our first step is to use Nmap to do the port scan of our target. So we just go in there and do so against that IP address. We can see in the results here we have ports 25 and 110 open, and those deal with SMTP as well as POP3. Next, we want to perform fuzzing, and to do this we will utilize a program called bed. But over on our Windows XP machine, we want to make sure that the target software is operational, which we can see that it is, and then we want to open our debugger, Ollie debugger, which is what we're using, and then attach it, file, attach, and go ahead and attach it, wait for those who are not aware, what a debugger does is it takes a program and it performs a disassembly, meaning it whatever program language it was written in, it presents that in assembly. In any case, now that our program is attached, we want to unpause it by hitting the play button there, and then we return to our Kali machine. To make use of bed, I have it in the pentest fuzzers bed directory. So since it is a Perl script, so we just do Perl and then bed PL, and then it's POP3, and then target 192.168. The administrator is the password, and then V is for... Eventually activity will cease while it's trying to input data into the password. If we go over into Windows XP, we can see that it has paused, and if we go look at the EIP, we see it's been overtaken by hexadecimal 41s, which represents A's. And that is what it has been fed by that bed script. So we know from this that the password field is vulnerable. So with that information, we can proceed forward with the development of our simple fuzzer Python script. Back over in the Kali machine, we have a simple fuzzer Python script. Up at the top, we have a couple imports. We have our socket set up there for our internet connectivity. And going down, we have some different variables that are commented out. I'll get to those later. We have the IP address we're connecting with right there, as well as the port. We'll be doing 110. That's the port that SLMail makes use of. User administrator, that's fine. So we just enter the administrator, which is the username, and then password. The password is password, and then right here is where we insert the buffer, and then we close the socket, and then we print a message letting us know that it's done. So the buffer, we can go back up here. Right now we're going to start out with writing 5,000 A's, and the hexadecimal 41 corresponds with A. So once we've done that, we just save it. Okay, and then Python, or simple fuzzer py. And then over in the Windows XP machine, I have logged back in. I have made sure that SLMail is running. and then I've gone into the debugger and I've attached it and I've unpaused it. So now we're ready to execute the script. Let's see what happens. Back over in the Windows XP machine, we go up and investigate and look at the ESP, and we see, or the EBP rather, and we see, oh, it's been overtaken by hexadecimal 41s, which corresponds with A's. Then if we click ESP and follow that in the dump, then we can see all of our A's that have occurred. Now that we know it takes at least 5,000 A's to overcome EIP, we want to figure out exactly how many characters it takes to overcome EIP. So to do that, we need to generate a set of unique characters. So over in Metasploit framework and tools, we can find something called pattern create. And then since we had 5,000 A's, we'll create 5,000 characters. And then once we have our output, go ahead and save that up in the script, which I have already done so right there. So now I will uncomment that out, which is the So now I want to uncomment out that and then comment out the 41s. Save it. And then execute the script. Back over in the Windows XP machine, we observe that the software has broken. We go look at the EIP. We notice 39794638. We want to make note of that because this is where exactly in that pattern of numbers where we had an exact match. And now that because this is Little Indian, we want this to be in reverse, which will be 38467939. So we want to make note of that. And then we need to convert that to hexadecimal. Over in ASCII to hex.com, we will go into the hexadecimal box. And we can translate the hexadecimal back to ASCII 2. And so we put that number in reverse since it's Little Indian, which would be 38, 46, 79, 39. And then we have our ASCII representation, 8, capital F, Y, 9. Back in our Kali machine, we want to make use of a different tool, the pattern _offset script. And then here we input our ASCII representation. And then since we had 5,000 characters, and I mistyped that, it should be Y. And then enter. Okay, so we see that we have an exact match that occurs at offset 4646. We want to make note of that. And then we go back over and modify our buffer so that we can confirm that that's exactly what's happening. So we want to comment out the other buffer. And then here I have 4646 A's, and then I'll have a series of 4 B's, which if everything goes according to plan, that will be the EIP. And then following that, we will have a sequence of 500 C's. And then go look over in the XP machine, and we see, oh look, our EIP has been overcome by a sequence of B's. and then I right-click the ESP, follow and dump, and we can see right there is our EIP, and then following that is a sequence of 500 Cs. Now that we see our Cs, we do recall that we had 500 of them, which corresponds to 500 bytes. Most payloads are going to be somewhere in the range of 300 to 500 bytes for a metasploit payload. So we're looking in the dump there, and we see the start of it and then the end of it. So what we want to do now is make note of the first full address, 01 C7A150, and then make note of the last address there, 01 C7A2F4. Now we want to calculate roughly how much space we have there. So now that we have those two addresses, we simply bring out the calculator, Windows calculator. I've gone to programmer 1. If I have the first address up there, and then we subtract that. By the second address, and then convert it back to decimal. And so we see we have roughly 416 bytes left in which to put our payload. So we should probably be okay then. Now that we've overtaken the EIP with our 4 Bs, we want to do a jump ESP instruction. In order to do that, we're going to open up the executables module, and we will look for a hard-coded jump ESP instruction. We can select any of these. We'll select shell 2. Simply click on it, and then just do a right click, and then search for, and then the command, and then enter jump ESP. And then any of these will work. We will select the first one, 7C9D30D7, and we'll make note of that. And it is in Little Endian, so we will want to do that in reverse. Back over in the Simple Fuzzer Python script, I have added the jump ESP with the hard-coded address that we found. I have modified the buffer, so now we have 4,646 A's, followed by our jump ESP variable, and then after that a sequence of 500 breakpoints, which is that's hexadecimal for the breakpoint. And now we simply execute the script. Back over in the Windows XP machine, we see our breakpoints right there. And then we see that the EBP is the 41s, and we go up above here, we see the jump ESP right there that we inputted. So everything appears to be in order. So the next step we have is the development of our shell code. Back over in the Kali machine, we're going to make use of MSF payload. Our shell code is going to be the shell bind TCP. We're going to use L port 443, and with the R stands for raw, and then we're going to pipe that out. And then once that's done, we want to encode the file, and the reason why we're doing that is we want to exclude bad characters. Bad characters can make the shell code nearly very difficult to run. Now the X00, that is almost universally a bad character, is to the other 3 characters. I looked at some other bad characters found in another SLM. Another way you can determine bad characters is to generate a shellcode, run it, follow it in the dump, and if any of the characters have been modified and that or is simply not present, then that is an indication that it's a bad character, and so then you would want to exclude it. So the I indicates file, B bad character, and then we are using that as what we're encoding it as, and then generate the shellcode. Once we have that shellcode generated, we want to go ahead and copy it, and then return to the simple fuzzy script, and then paste it up above there, which I have done so. And then we'll want to go down and modify our buffer once again. So now we have a series of 46 hexadecimal A's followed by our hard-coded jump ESP location. And then here we have a NOP slide of about 25 NOPs, so that if something goes wrong, we have a little bit of safety room there. And then following that, we have the shellcode above, and then for debugging purposes, at the end we have another NOP slide. And so then we simply save it and then run it. Back over in the Windows XP machine, we have the software service started. I do not have it attached to the debugger. I have gone ahead and run a netstat command, and we see that port 443 is not listening. So now we go ahead and return to Kali and then run the script. We see that something has happened. It doesn't display that it's done. So we go back to the Windows XP machine and then check and see if port 443 is waiting for us. So now we can return back to our Kali machine. Now we could do a variety of things. We could telnet, we could do netcat, so I'm entering the target IP address as well as port 443. And success, we now have access to the target. Now there are a lot of different things we could do. For instance, we could add a new user, give it a password, and perhaps we'll decide to make that person an administrator. And perhaps we want that person to have their account expire in a day. That way we can use it and then it can go away when we're done with it. Beyond this, there are many different possibilities as to what you could do. For instance, you could obtain the Windows executable version of netcat and then transfer that over and then use that as your backdoor, and then you could transfer Hacker Defender over and use that to set up a rootkit so that you can have make sure that netcat is always going to start and is hidden, and that way you could always remotely connect to the target. But with that, I would like to conclude this demonstration.